Welcome to Build Bytes Daily. What if I told you that one of the most common lines of code you write every single day is, well, it's also one of the most dangerous? Today, we're going to dig into the hidden danger lurking inside JavaScript's oldest async pattern, and more importantly, how to sidestep it. So, what is it? What's this incredibly dangerous line of code? I promise you, it's not some crazy, complex algorithm. It's something you probably type out multiple times a day, almost on autopilot. And the danger here isn't a simple syntax error. No, it's a fundamental risk baked right into the DNA of a classic JavaScript pattern.
And that pattern is the humble callback function. Yep, it's the absolute bedrock of asynchronous JavaScript. It's probably the first tool any of us learned to handle stuff that doesn't finish right away.
The definition itself is super straightforward, right? You just pass a function, your callback, into another function. Let's call that one a utility. The whole idea is for that utility to run your function later, once it's finished its main job. It's basically you saying, hey, go do this thing, and when you're all done, call me back. Simple. So you've got your code that's running right now, and then you just hand off your callback to some other piece of code to execute sometime in the future. On the surface, this looks totally fine. It works. But this simple act of handing something off, that's exactly where the danger is hiding. See, the problem isn't really the callback itself. The real issue is a tricky concept called inversion of control. It's not about what gets called, but all about who is in charge of calling it. So when you pass that callback, you are literally giving over control of a part of your program's execution to someone else's code. You're just trusting that this third-party utility is going to call your function and call it correctly. It's kind of like handing your car keys to a valet you've never met before and just hoping for the best. Wait a minute, so you're just trusting this utility to run your code and to run it exactly once with the right data and at the right time? That sounds risky. Exactly. And most of the time that trust works out just fine, but when it doesn't, the consequences can be a complete disaster. Let me tell you a little story, a real-world scenario, to show you why this trust can be so misplaced. Okay, picture this. You're building a travel booking website. To handle all the tricky payment and booking transactions, you decide to use a really popular third-party library. I mean, it's popular. What could possibly go wrong? Your code is clean, it's simple, you call the library's create booking function, you pass in all the booking details, and then you pass in your callback, send confirmation email. And right there, in that one moment, you've just handed over control of sending that critical confirmation email to the library. Oh no, a customer just got four identical confirmation emails for one single booking. The support lines are absolutely blowing up. What on earth just happened? And here's the kicker. The bug wasn't in your code. It was deep inside the third-party library. Turns out some experimental code they pushed caused their utility to call your callback 4 times instead of just once. Because you gave up control, a bug in their code became a nightmare for your users. So the team scrambles. They start writing defensive code. They wrap your callback logic in this clunky if statement to make sure the email only gets sent out one time. It's messy, it's a patch, but hey, it stops the bleeding. For now. Okay, that patch might stop the multiple emails. But what if a different bug pops up and they just never call the callback at all? Now the customer doesn't get any confirmation email. That's just as bad. And you've just hit on the core of it, this crisis of trust that comes with inversion of control. That third party might call your function too early or too late, or, like you said, never. They might call it too many times or not enough. They could even swallow critical errors, leaving you completely in the dark. You end up having to write more and more of that defensive code, and your whole codebase just gets more and more complicated. So we're stuck in this fragile relationship of trust with basically every third-party tool we use. But what if we could just flip this whole relationship on its head? What if, instead of handing our function away, we got something back, a guarantee that we could use to decide what to do next? Think of it like this. Using callbacks is like hiring a private chef and just handing over your entire kitchen. You just have to trust them to make you dinner. A promise, on the other hand, is like ordering at a fast food counter. You place your order, and they give you a receipt. You don't give them control of your kitchen, you just hold a little ticket that guarantees you'll get your food, eventually. That receipt, that ticket, that's a promise. It's this special object that acts as a placeholder for a future value. It promises that the operation will either complete successfully or it will fail. It's basically a container for a future outcome that you get to control. All right, let's go back to our travel booking nightmare and see how a design based on promises completely solves the problem and, more importantly, puts the power right back where it belongs, in our hands. Remember this? The before code is, well, it's a mess. We were literally forced to write that clunky, defensive if statement inside our callback, all because we couldn't trust the utility that was calling it. Now look at the after code. It's so clean, so readable. The create booking function gives us back a promise object. Then we just use .then to say on success, send the confirmation email, and .catch to say on failure, handle the booking error. We are dictating the entire flow. And here's the magic trick. Once a promise is settled, either fulfilled or rejected, its state is locked in forever. It's immutable. You can't change it. This means our multiple email bug is now literally impossible. The promise can only resolve one time, which means our .then can only ever be triggered one time. The problem is solved at a fundamental level. And, this isn't just about writing prettier looking code. This is about writing software that is more predictable, more reliable, and ultimately more trustworthy. It's really about managing risk. So here's the main takeaway. Callbacks invert control, handing authority over to someone else's code. Promises are what you could call an inversion of the inversion. They take that inverted control and they flip it right back, restoring the authority to your code. You get a predictable, chainable value that puts you back in the driver's seat. Now, this whole idea of inversion of control, it doesn't just apply to async stuff. So the question we want to leave you with is this. Where else in your own projects have you unknowingly given away control? And more importantly, how can you take it back? If you found this useful, and we really hope you did, don't forget to like and subscribe to Build Bytes Daily. Thanks so much for watching.